Hello, my name is Hudson Lyon. I'm a freshman at Centennial High School, and this is my science fair project. So the topic I am studying is whether or not you can make reusable energy using the spinning of wheels, like for example, bike wheels. Also, I was wondering if I can charge my phone using this energy and how long it would take to charge my phone from 1 to 100%. Now on to the materials. I used many materials that had to be a specific type or voltage or shape in order for this project to work, and I think it was worth it. Here's a list and video of all the materials I used. So I used a mountain bike that I own, and it has gears, and I took off the back wheel and replaced it with a drive belt, which I believe is 81 inches, and then I attached that drive belt to a motor with a circular pulley on the other side with a 1/2 inch divot in it, and I connected the wiring of the motor to a battery, and the positive end I put a diode on so that the motor can power the battery basically. And then I connected the ends of a power inverter to the battery, and the power inverter has a plug on the other end so that you can plug in a phone or a lamp to it. And when all of those parts are put together, you have this invention. So you can see the bike with the drive belt attached to the back wheel, and that drive belt's attached to the motor, and you see the diode and all the wiring connected to the battery with the inverter plugs on top of them, on top of the wires. And you can see that the lamp in this case is plugged to the inverter, but I'll be using a phone for my project. Now it's time to test my project, and I'll be showing you guys a video of me testing it. Let's get to it. I switched out the lamp for my phone because I wanted to test to see how long it could charge my phone for. So this is a time-lapse video of me conducting my experiment, and you can see my brother every now and then popping in to check on the percentage of the phone. So my experiment was going well, we were getting data, everything was fine, and then Mother Nature decided that she wanted to stop me in the middle of my experiment. Really, Mother Nature? Really? You had to start raining in the middle of me conducting experiments? Why? But anyways, I put my project back over here because I had to disassemble it really quick because it started raining out of nowhere. So I was able to collect some data, and the data I collected was that the phone charged to 5% in about 3.5 minutes. And I multiplied 3.5 minutes by 20 to get 70 minutes because 5 is 1/20th of 100. So that means it's gonna take about 70 minutes to charge the phone to 100%, as opposed to my control data, which was that the phone charged to 10% in 15 minutes, which means that if you divide 15 by 2, you get that the phone charged to 5% in 7.5 minutes, which is amazing because that is double the time it took to charge the phone using the bike, which that went against my hypothesis. My hypothesis was that when the phone was plugged into the bike generator, it would take double the time to charge it to 100% than when it was plugged into a standard wall outlet, which obviously that wasn't the case, and that really amazed me and helped me learn something new, that hey, the bike generator actually probably generates more power than the average outlet plug. So the conclusion I came to was that the bike generator actually does generate more power than a standard outlet. And that's actually really surprising for me because I really thought that the bike would not generate as much power because it's coming from a small motor and a 12-volt battery. But yeah, I was glad I learned something new, and I hope to conduct more experiments like this and test to see if the bike generator can generate and power more things. What the great thing is about this bike generator is that the motor, when the motor spins, it conducts electricity, and that diode lets the electricity go into the battery so that the battery never runs out. So I could be pedaling for days and days, and the generator, like the battery, would never run out because the motor just keeps giving energy to the battery, so that the battery can power the inverter, which can power like a light, let's say, or a phone, and keep charging it for days on end. So yeah, thank you for watching this. My name is Hudson Lyon, and this is my 2019 science fair project.